Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into activity 7F2 here and kind of stem off what we talked about in 7F1, where we talked about end behavior. What's happening to the function values as you approach negative infinity, and what happens to the y values when you approach positive infinity. What happens with that end behavior? So what we're going to do though is we're going to evaluate the function using tables here, but we're not going to do it typically. We're not going to use a T84 or a scientific calculator. We're going to learn something new. All right. So what do the function values tell us about the end behavior of these polynomial functions? And so what we're going to do is we're going to learn how to evaluate a function using Desmos. So this is a Desmos activity here. So we're going to be using Desmos instead of the TI-84 or scientific calculator to evaluate the function at all these different values. Okay, and then what we're going to do is we're going to describe the end behavior using symbolic notation like we did in 7F1. So here we go. Let's get started. So what we're going to do is we're going to go to Desmos. You just type in desmos.com, or you can use this on your phone like you're used to doing with me in class. But on your computer, just go to desmos.com like I'm going to do, and we're going to enter the functions in. Okay. Now, this is my activity. Of course, I'm already ready for it. You're going to have to enter the functions in. So I'm just going to go through it just for funsies here, assuming that you have not done this before. So hit the plus sign. We're going to enter in a function. So we select f of x, and let's say you haven't entered these functions like I do. So I'm going to enter in the y1 here, which is from our activity right here. Notice it's the same thing, negative 2x cubed plus x minus 1. It's a polynomial cubic function. And what we're going to do is we're going to enter that in. So let's go back to Desmos. So I open up the keyboard down here in the lower left-hand corner is your keyboard. And you could type this in with a keyboard, or you can just use this digital keyboard right here. So type in Y and then hit 1. It automatically puts a subscript in for you. All right, equals negative 2, so minus 2x, and then you hit the squared button. Oh, excuse me, it's cubed, so hit the a to the b power. That's your exponent button here. Let me go back here. I got to put a cube in. So you hit a to the b power, and then you hit 3 for the cubic, for a cube right there, negative 2x cubed. Then you got to get out of the exponent. So you hit that right arrow key, all right, and then you got to plus x minus 1. So plus x minus 1. And notice it's the same as above. All right, that's how you would enter the function in. All right, so I don't need it twice. So you enter the function in just like I did. If you hit the little symbol right here, you'll see it. So notice that it's this cubic function that you've seen before in Algebra 2. Remember, we're in MRWC, which is a pre-calculus based course. In Algebra 2, you discussed polynomial functions and behavior, but now we're getting into a deeper discussion about it, really learning about it. What happens to the y values when you go to the left on this function? Like here, what's happening when you go to the left? What happens when you go to the right? Okay, what happens to when I say that? What happens to the function values? I'm talking about the y values. Look at the y values. So they, maybe they're start at 0. Well, actually, if you go from left to right, they're up there at 13. Notice they're decreasing. Now we're at 6.8. Now we're at 2.4. Look at the y values. Now we're at 0. And then it goes up and then to relative max and then back down again. So, but what happens to the end behavior? So let's analyze it numerically using a table. So we're going to do something new. We're going to learn how to put a table in. So you go to the plus sign, select table. Okay, so now what I want to do is I want to change my headings on my XY table up here. So my function is y1 because I'm going to enter two different functions. So my first one's going to be y1, the second one's going to be y2. If I had a third one, I'd call it y3, etc. So I got to change my labels, and y1 is in terms of x and not x sub 3. So I got to change this first. So you can just clear it all out if you want. Ooh, you don't want to do that. Okay, I don't want to destroy it. So you clear it out and you clear that subscript, and now x is our variable up here in y1. Now we want to reference y1, so I'm going to change my subscript here. What you could do is you could highlight it all and just copy paste. So what I could do is I could go up here, I copy it, go Control C, is copying on the PC, and then come down here, and then Control V is paste. And then you need to put in some values. And in our table, and let's go back to the table and take a look at it. We got negative 1,000, negative 100, and then negative 50, and then negative 10, and then 0, and then the same thing but positive. Okay, so let's put those values in. So I'm going to start off with negative 1,000. And notice that it evaluates the function for you automatically. You get to enter if you want, and it goes, if I hit enter, it just goes down. And then you type in negative 100, enter, and then negative 50, enter, and then negative, I think it's negative 10. Yep. So negative 10, and then enter, and then 0. Let's put the 0 in. Now, if you put 0 in, you should get negative 1 back, right? Negative 2 times 0 cubed plus 0 is just 0, and then minus 1 gives you a negative 1. So we know this is making sense. And then you just repeat the values but make them positive. So hit enter, and you'll just keep on going down. So positive 10, enter. 50, enter. 100, enter. And then 1,000. And then voila, the table is generated. It just evaluated the function at 9 different points. Okay, and then what you can do is you just write down your values. And by the way, this is 1.99999 times 10 to the ninth. This is scientific notation. So if I was going to write this out, you guys, I'd have to shift the decimal place 9 places to the right, which is a huge number. Huge. All right. All right. It is huge number. That's big. All right. So let's grab this table here. I'm just going to do something cool in my lesson right here because I need the values. All right, now you guys just write them down in your table, okay? But I'm going to grab those values. So I'm going to do something cool, technically speaking, right here. I need these values. So let's grab them. All right, and here they are. So I'm going to clean this up just a little bit. So give me a second. Okay, so here we go. So there's your table for the first function, and now we can analyze it. So let's do that. So it says analyze it numerically. Okay, so we're not looking at the graph here like we did in 7F1. We're looking at the values. So here we go. Let's start off with here. So I'm going to go to the left. All right. So from 0 to negative 10 to negative 50 to negative 100, you're moving left on the x-axis. So as x gets increasingly more negative, which means it's going to negative infinity here, what are these y values doing? Well, at 0, this is our starting point right here. What are the y values doing as x gets more and more negative? As we move left on the x-axis, what are the function values doing? Well, just look at it. It goes from negative 1 to 1989 to 2,449, 249,949, which is it's a 6-digit number. It's fairly big. But now we're getting even bigger. Now you're in the millions. All right. So when you move that decimal 1.999899 6 places to the right, you get a much, much bigger number, right? It's getting infinitely large. It's increasing without bound, okay? So we say that y is approaching positive infinity as x approaches negative infinity. It's increasing without bound. Increasing, all right, without bound. All right, if I continue this, if I entered in negative 1 million, let's say, I would get an astronomically large number. And the reason why is because if you look at the graph, let me zoom out here. All right, if we move to the left, these numbers get increasingly large. I mean, look at the y values. It goes up, up. So a little movement left, it shoots way up. It gets increasingly large. I mean, like really large. So just like right here at negative 2, y is 13. 2 units to the left, and now y is over 100. So, and that happens with these polynomial equations. So as you move to the left, the function values get extremely large. They increase without bound. Okay, so like I said, as x approaches negative infinity, y approaches in positive infinity. Now, what has happened the other direction? So as x gets more and more positive, so as x approaches positive infinity here, right, from 10 to 50 to 100 to 1,000 to a million to 10 million and so on, What are the y values doing? Well, they're getting more and more negative. Look at that, from -1 to -1999 and so on. All right, y is approaching negative infinity here. Positive infinity upward here when you go to the left, but negative infinity when you go to the right. All right, because they're decreasing without bound. Decreasing, all right, without bound. There's no stop to it. That's what decreasing without bound means. This is going down and down. So if you just take a look at the graph, I mean, let's do that. So a little motion to the left. If you cruise to the left a little bit, ooh, look at these y values. They keep on getting more and more negative. With a teeny little movement to the right, you're now decreasing very quickly. All right, and that's what happens with this cubic function. Now let's take a look at the other one. Let's look at the x to the fourth minus x cubed, which is a fourth degree function, not a third degree. They're both polynomial functions. Okay, they're polynomial functions, but this is a fourth degree um, function with a positive lead coefficient. This is a third degree. This is a cubic function. This is called a quartic, okay, or a fourth degree. And this cubic is third degree. Okay, so and what happens here? So let's practice again. Let's go back to Desmos. So let's deselect these and let's go to the next function. So next function, you got to type it in. So just type it in directly, y2 and then so on. Once you type it in, you're going to add a table. So go hit the plus sign, go to table, and you're going to change this. The first column here should just be x and not x to or x sub 3. So take off the subscript, and you want y2. So what you want to do is copy y2. So you go highlight it, Control C, come back over here, Control V, or you just type it in, either way. And then what you want to do is you want to enter the values in. So let's go ahead and start off with -1000. And notice that it evaluates that for you. And notice this is a 13-digit number. If you shift the decimal to the right 12 places, because this is scientific notation, when the exponent's positive, 10 to the 12th power, you have to shift the decimal right 12 places. That is a 13-digit number. It's huge. So you go left 1,000 units and you go up in the billions or in the trillions. Okay? Actually, it's bigger than that. It's huge. 12-digit numbers are huge. And so you go hit enter and then -1, what was it, -500? No, -100. Let me see. What did I do here? Yeah, so -100 and then -50. And then you hit the enter button, -10, enter, 0, enter, 10, enter, 50, enter, 100, enter, and then 1000, enter. And then you will see the table and you'll see the values. So let's go ahead and capture this. And let's bring this into our lesson again so we can analyze it. So I'm going to do the same thing. I'm just going to clip it in. This is why you get something like the Surface Pro or some kind of tablet. You can do all this stuff like I do and do your homework digitally. I highly suggest it. My son has it, and I teach him how to do what I'm doing, and so he does his homework digitally. Okay, so I'm just doing Control C, Control V to copy paste. Okay, so now we have the second function in. So notice it's the same right there. So it's the second function. You just write down your values if you want. So let's analyze. Here we go. Let's play the game again. All right, so our reference point is 0, 0, 0. If you put 0 in, you obviously get 0 back because 0 to the fourth minus 0 cubed is obviously 0. That's obvious. All right, so if you cruise to negative infinity here, like Buzz Lightyear, okay, so as x approaches negative infinity, what are the y values doing? Well, it goes from 0 to 1100, or 11,000, excuse me, which is not very big. And then now you're a 7-digit number, so you're over a million. All right, you're over it's like 60 million. So this is huge. These are big numbers. And then you have a 9-digit number and then a 13-digit number. These are huge numbers. This is absolutely huge. All right, it's a huge number. So y here is increasing without bounds. We say that y goes to positive infinity. It's increasing, all right, without bound. Okay, now if you take a look at the graph, let's do that because I forgot to select the function. So when you select the function, notice what happens here. Look at that. When you go to the left, as x goes to the left, it starts with -2, -3, -4. Look at the x values. Look at the y values though. A little movement left, and the y values are taking off. They're skyrocketing. All right. So on this quartic function, fourth degree function here, as you move to the left, the y values take off up to positive infinity. Same thing on the right. Okay, if you go to the right, the y values increase without bound. They go to positive infinity. And we've talked about this before, so hopefully this is making sense because we've done this before in previous activities with polynomial functions. So down below, as x approaches uh, positive infinity in this case, from 0 to 10 to 50 to 100, it's going to positive infinity. Okay, what are the y values doing? Well, they're getting astronomically large, so they're going to positive infinity as well. You can see that on the right side of the function. You just analyze it. You look as you move right on the graph. Look at the function values, the y values. They're huge. All right, look at that. Over 500. Okay, at 5.3, 5.03, you're at 515. I mean, they get huge fast. Okay, so both x and y are going to positive infinity. And in this case, on the left side though, this is the left side. So going left, so moving left, okay. Y is going to positive infinity, which means it's going up, okay. Going up as you're moving right. So here you're moving to the right. Here, y is going up. So y is going up. It's going upward without bound. Okay, it's going up. So it's just in simple terms. They're increasing. The y value is increasing. That's what it means to go to positive infinity. So what you guys are going to do is you're going to use Desmos and you're going to learn how to create tables for your functions. And then you're going to write down the y values in your activities and you're going to analyze it like I do. Okay, as x approaches to the left or goes to the left, what happens to y? So in other words, as x approaches negative infinity, what are the y values doing? As x approaches positive infinity or to the right, what are the y values doing in your functions? So what's cool about Desmos is you're going to get 2 for 1 because when you look at Desmos, you have a table and you also have the graph. So what you interpret in the table should match how you interpret the graph and back and forth. That's why I love Desmos or GeoGebra or some kind of software like this is that it is so useful and it's easy to use as I just illustrated. Okay. By the way, just so you know this, before this lesson here, I didn't know how to enter the table in. All right. So what did I do? I went to YouTube. I YouTubed it, and in just a matter of a minute, I figured it out with a couple exceptions. Then I just used my deduction skills, and I figured that out too. So just go ahead and get used to this tool called Desmos because it is your best friend. All right, and then when you get to your activity, which is coming up here, 7F2, all right, you're going to be doing the same thing. So in respect to this, you're going to be using Desmos, not the scientific calculator. So you want to get skilled at this. All right, use Desmos, and then go through the entire activity, write down your results. All right, and we will, oh, and you notice how there are no x values here as I wrote down up here. So what you can do if you wanted to is you could use the same values as we used in the previous um, discussion here. So in other words, you could go, so let's say zero's in the middle. So 0, if you go into negative infinity, so this would be -10, -50, -100, -1000, excuse me. So use the same values, and then over here on the right side, as you go to positive infinity, that'd be 10, 50, 100, 1000. Just use the same values as we did before. So when you analyze these functions here, and then we'll see what happens. Uh, in your discussions, okay? And if you have any questions, just let me know. You can get a hold of me through Remind if you want. Anybody can do that and have a private discussion, or you can put some questions up on the Google Classroom as well, too. Okay, so make yourself proud, work hard, and I'll see you in the next Hangout. We'll discuss this activity then. This is Mr. Ainsworth. I'll see you soon.